Which ADC architecture is right for your application? Introduction. Selecting the proper ADC for a particular application appears to be a formidable task, considering the thousands of converters currently on the market. A direct approach is to go right to the selection guides and parametric search engines, such as those available on the Analog Devices website. Enter the sampling rate, resolution, power supply voltage, and other important properties. Click the Find button and hope for the best, but it's usually not enough. How does one deal with a multiplicity of parental best choices? Is there a way to approach the task with the understanding and the results? Most ADC applications today can be classified into four broad market segments: A. Data acquisition, B. Precision industrial measurement, C. Voiceband and audio, and D. High speed, implying sampling rates greater than about 5 MSPS. Here's a video about ADC application.
The ADC Applications Property Module provided by DigiKey and Analog Devices Incorporated provides information on how to select the appropriate analog to digital converter ADC for various applications. Learn how multi-channel data acquisition and distribution systems, which are the backbone of many industrial and instrumentational applications, utilize ADC technology. Discover how a resolver to digital RD converter can be used in motor control applications in which high voltage and current levels need to be monitored to obtain accurate information on motor position. Read about ADCs used in broadcasting applications and precision ADCs that provide high accuracy and fast throughput. Please visit www.digitcom.
Successive-Approximation ADCs for data acquisition. The Successive-Approximation ADC is by far the most popular architecture for data acquisition applications, especially when multiple channels require input multiplexing. From the modular and hybrid devices in the 1970s to today's modern low-power ICs, the Successive-Approximation ADC has been the workhorse of data acquisition systems. Sigma-Delta ADCs for precision industrial measurement and instrumentation. Modern Sigma-Delta ADCs have virtually replaced the integrating type ADCs, dual slope, triple slope, quad slope, etc. for applications requiring high resolution, 16 bits or 24 bits, and effective sampling rates up to a few hundred hertz. High resolution, together with on-chip programmable gain amplifiers PGAs, allows the small output voltage of sensors such as weight scales and thermocouples to be digitalized directly.
The ADC Architecture's Product Training Module, provided by DigiKey and Analog Devices Incorporated, discusses the advantages and disadvantages of three ADC architectures. Learn about successive approximation ADCs and how they work well with discontinuous and multiplex signals. C1 is the most widely used architecture for medium resolution and medium speed. Read how Sigma-Delta converters are able to get extremely high resolution at low data rates and why they are currently limited to applications like measurements, voiceband, and audio. Finally, discover why pipeline ADCs are the most commonly used architecture in high-speed ADCs and why they suffer from latency or pipeline delay. Please visit www.
Sigma-Delta ADC for voiceband and audio. In addition to providing attractive solutions for a variety of industrial measurement applications, precision measurement, sensor monitoring, energy metering, and motor control, the Sigma-Delta converter dominates modern voiceband and audio applications. A major benefit of the high oversampling rate inherent in the Sigma-Delta converter is that they simplify the input anti-aliasing filter for the ADC and the output anti-imaging filter of the DAC. In addition, this ease of adding digital functions to a CMOS-based converter makes features such as digital filter programmably practical with only small increases in overall die area, power and costs. Pipelined ADCs for high-speed applications, sampling rates greater than 5 MSPS. Today, markets that require high-speed ADCs include many types of instrumentation applications, digital oscilloscopes, spectrum analyzers, and medical imaging. Also, requiring high-speed converters are video radar sampling, software radio base stations, set-top boxes, etc., and consumer electronics, digital cameras, display electronics, DVD, and high-definition TV, and high-definition TV.
Why would you need an application controller to front-end your Microsoft environment? The discontinuation of support for Microsoft TMG is one of the top reasons. You need a solution that can provide the same secure reverse proxy features offered by TMG while providing faster access to email over the web and 100% application availability. When it's time to upgrade your Microsoft environment, it's vital to understand how deploying an ADC will not only help future-proof your infrastructure, but also save you on extensive build-out and management costs. Applications are the lifeline of any business. As users leverage the web more and more to access their applications, data, documents, and messages, demands on your servers are at an all-time high. Things to just always work. The moment it doesn't, you're the first person called to fix it. IT's a funny job. If you're not hearing any complaints, that's usually a pretty good sign that you're doing a good job. What if you could guarantee that users will always have access to email, even during your exchange maintenance windows? What if every single user in your company experienced a 5 times increase in performance and speed while collaborating or downloading documents on SharePoint? You think that might get positive attention? NetScaler is designed to do exactly that. It was voted the MSExchange.org Reader's Choice Award winner for Load Balancing Exchange, built from the ground up to ensure intuitive with your mission-critical Microsoft applications. Easy to implement using clear, concise deployment guides that are certified by Microsoft. You can also apply App Expert templates, custom templates that automatically configure your device to the recommended settings.
Conclusion. We have discussed here Successive-Approximation, Sigma Delta, and pipeline architectures, those most widely used in modern integrated circuits ADCs. Successive-Approximation is the architecture of choice for nearly all multiplexed data acquisition systems, as well as many instrumentation applications. The SAR ADC is relatively easy to use, has no pipeline delay, and is available with resolutions to 18 bits and sampling rates up to 3 MSPS. For a wide variety of industrial measurement applications, ADC is ideal. It is available in resolution from 12 bits to 24 bits. Sigma Delta ADCs are suitable for a wide variety of sensor conditioning, energy monitoring, and motor control applications. In many cases, the high resolution and the addition of on-chip PGAs allow a direct connection between the sensor and the ADC without the need for instrumentation amplifier or other conditioning circuitry.